So as we spoken last time, this is the window of robot, and since I'm going to work with a 2D beam, I'll go to new, and I'll go to 2D steel beams. And as I've told you in the last time, my default settings are on the Eurocode, and my default material is S355, and then so I don't have to do that step again. I can start drawing directly. So I'll draw the axis first. And since we are using 2D, once again, we have only X and Z. And the X's, let's remember our beam. These are they. So how much should I draw? So I'll draw 2. It's preferable to draw the minimum values in your distances that you have. Now I can draw 6 meters and then 6 meters and then 6 meters. And then I can draw the 2. And this is what I'm going to do for you. It's because it's going to be a new thing. So first we are in the position 0, and I want the repeat to be 3, and each one of them is 6 meters. And add. Then I'll go to Z. I need nothing but a single 0 axis, and then I'll press add again. So I have now the grid that I'm using. Apply. And okay, this is the grid that I'm going to draw my beam in. This is going to be the first span, the second span, and the third span. Now I'll go to draw bars. And I'll go to new section, and it's going to be an I-BISM section. It's going to be from the family of HEB and HEB 300. Add, and then it has came to here to the drawing order. Now this is my first span from here to here, and then from here to here, and then from here to here. Now I'll close it. I can see the real shape of my beam from pressing this one and then this house. And then there is it. Now, wheeling, the mouse wheel is for zooming, yes, of course, but pressing it with the shift makes you rotate around the point that you want. So you press shift and the wheel mouse, then you can rotate like this. And then I'll go home. I'll go to the XZ elevation again, and I'll turn off the section shape. Yeah, XY. So this is XZ. Now defining the supports, this joint and this joint and this joint and this joint are all pinned loads. So I'll go to here and pin load and apply. I'll save my works on desktop. Now I have to define the points where I have to draw my concentrated loads. I can do that manually, just geometry nodes. So I can draw a node wherever I want to. Or this is the window of addition or modification on beam. So I'll press on it and I'll get it to here. And I'll select this beam and I'll tell it divide it for me, please. Division. You can divide it into many parts, either the number of parts. So you can tell it divide it for 3 parts for me, please. Or you can divide it by distance. Divide it after a meter, or you can divide it by a relative distance or by a plan. I'm going to divide it in 2 parts. And how many parts do I need?
3.
Yes, 3 parts. In here there is an important check. Generate nodes without edge division. If I kept this one, it won't divide the beam. It will only give me points. But if I turned it off, look what would happen. Then execute. It will turn to 3 beams. Come on. So 1, 2, 3. I don't want this. I just want nodes. If you've done this, then this is wrong. Because they are not 3 separated beams. No, it's a single beam with 3 different points. So Ctrl Z, and then I'll choose it. I'll check the check and select, and then execute again. Now the nodes has been drawn. How can I see that? I'll turn off the section shape, and in here there is node numbers. If you press it, it will show you the numbers of nodes. So this is node number 1, 7, 8, 2, 3, 4. So I'll do the same for those 2 beams, this one, and divide it and execute. There are the points that I have to assign my concentrated loads to. Okay? So I'll close it, I'll turn off the numbers of the nodes, and I'll save it. Now I will define the loads. I'll go to loads, load types. The first one is dead weights. as I like to name it, and I told you that it includes the self-weight automatically. And the second one is a live load, and it's going to be LL. I can use the category or not. I will not, because I don't care, because I'm defining the combination manually. So add, close, and save. Now what loads should I assign? I have to assign a rectangles of 6 along the whole beam. This is a dead load and this is a dead load. Those concentrated loads above. So I'll go back to the robot. I'll choose this opening and this span and this span. And I'll go to assign loads, load definition. From here, I'm defining on a bar. I want to define a dead load and then a uniform distributed load that is equal to how much? -6. It was 6. So add, apply. There is it. And I can see the value of it by turning on those two. So it's -6. Now I choose those points. And I'll go to nodal loads, nodal force, and it's on Z -63.6. Let's check it. Yes. And add and apply. And now you can see that these are the dead loads, the distributed loads and the concentrated loads. Now, if I have found during my calculation that I want to modify a value, what do? Do I have to delete it and reassign it? No, you can do the next. Right-click, tables, loads. Okay. And now it will show you that first you have the self-weight assigned. It's automatically taken. And you can see whole structure. So it calculates it automatically and includes it automatically. And then you have a uniform load distributed on element number 1 and element number 2 and element number 3. So this 1, 2, 3 means 1, 2, 3. And the value of it is -6. And then you have a nodal force at the points of, and this is its value. So in here you can know, am I assigning correctly or not? Now you go back to view to assign the live loads. I'll turn off the loads again. I'll choose 1, 2, 3, and it has to be a live load. Then I'll go to load definition, a bar, uniform load, -3. Add and apply. And again, I select the nodes, a nodal force, and in here, and it's -30. And I can see the values again. This is the distributed -3, and these are the nodal force that they were 30. I'll save the works. I'll close those two. So turn them off. I'll turn off the node numbering. Now I'll define the load combinations. Manual combination. The first one is 101, and it's 1.35 DL plus 1.5 LL. Okay, and this load amplified by 1.35, please, and take it to the right, and the live load 1.5 and take it to the right, and apply. The new combination is an SLS combination in 201, and it's going to be dead load plus live load. Okay, so those two, amplify them by 1, please, and take them to the right, and apply, and the close. So now you can see you have the dead weights, you have the live loads, you have the two combinations. I'll save my works, and I'll do the analysis, calculations. Now in here, in robot you have two types of warnings. We have nothing now, but in robot there is warning and there is error. If it's a warning, it will give you results, no problem, but an error stops the calculation. The error will not give you results in case of error. You have to fix the error, but a warning is okay, you can continue working. So in here, if you could have seen, there's a warning of isolated nodes. Isolated nodes means a node that has no support, which are those nodes for us. This one, this one, this one. So usually every time you're using robot, you will see this warning, because of course I will have isolated nodes. So now the green light is open down there, so the results are okay. I can see the results. I go to results, diagram for bars, parameters. I like labels, different and field, apply, and then I'll go to NTM, and I want MY moment and apply. This is the minimax. I'll go to the combination of 1.35, and these are the bending moments of mine. So the maximum value in a positive span is 231, and in the negative span is 260. So in here we can see it's 230 and almost 260 in here. And for the shear, it's Fz. These are the shear values. So the maximum value is 216 kilonewton. And for the reactions, I can go to reactions and I press, okay, I'll turn off the shear first. So turn off the shear and then go to reactions and then choose Fz and choose descriptions and apply. So this will be the reactions from the dead loads, and these will be the reactions from the live loads. You can take those reactions to use them where? On the columns. Okay? So now we have the maximum applied bending moment and the maximum applied shear forces. So I'll stop the recording here.